welcome back to our channel. Today in this video we can discuss about the reduction formula for integral of sin raised to n into x into dx. The question is that prove that integral of sin raised to power n into x into dx, which is equal to minus 1 upon n sin raised to n minus 1 into x into cos x plus n minus 1 upon n into integral of sin n minus 2 x into dx. Then proof. Here firstly we have to consider, let I is equal to integral of sin raised to n into x dx. It is equation number first. Then here we can split this sin raised to n into sin raised to n minus 1 into sin raised to x. And if we add this index of the sine function, then n minus 1 and here index is 1, then n minus 1 plus 1, so it will become sin raised to nx. Therefore for the solution method we can adjust this as sin n raised to x as integral of sin raised to n minus 1 x into sin x into dx. Then here it is a two function, then we can use here product rule, that is integral of u into v, that is integral of u into v, that means integral here first function as it is and into integral of second minus integral of derivative of first function into integral of second function. Then here we can use integration by parts rule. Then here first function as it is, that is sin raised to n minus 1 into x, here sin raised to n minus 1 into x. Then integral of second, here integral of sin x into dx, here integral of second minus integral of derivative of first function, that is d by dx, that means the derivative of here first function is sin n minus 1 into x, here sin n minus 1 into x into integral of second function, that is integral of sin x into dx, integral of sin x into dx. Then here sin n minus 1, sin raised to n minus 1 x, here it is as it is. Then integral of sin x into dx, integral of sin x, it is minus cos x, here integral of sin x, it is minus cos x. Then minus here integral of derivative of sin raised to n minus 1 x. Then here we can use the power function, that is sin what we can say, that x raised to n, then x raised to derivative of x raised to n, it is n into x raised to n minus 1. Then here n is n minus 1, therefore n minus 1 into sin raised to, here n minus 1 minus 1, it is n minus 2, here sin raised to n minus 2 into x. Then again by the chain rule, here we can find the integral of we can find the derivative of here power. Then we have to find this function's derivative, that is sin x. Then derivative of sin x, it is cos x by the chain rule. Then here integral of sin x into dx, it is integral of sin x, it is minus cos x into dx. Then here minus takes firstly, then which is equal to minus sin raised to n minus 1 x into cos x. Then here it is plus this minus and this cos x minus, it becomes plus. Then plus here n minus 1, it is a constant, therefore we can adjust this on the out of integral. Then n minus 1 into integral of, here what terms will remain, it is sin n minus 2 x into here cos x into this cos x, it will becomes cos square x into dx. Here this minus sin and this minus, it will becomes plus, and here n minus 1 as it is. Then here sin n minus 2 x into cos x, cos square x, this cos square x is also denoted by, or it will also mentioned in terms of sine. Then we have to use here cos square x is equal to 1 minus sin square x. Cos square x is equal to 1 minus sin square x. Then we will replace this cos square x in terms of 1 minus sin square x. Here this all terms as it is, if all terms as it is except here cos square x, we can replace this cos square x in by the 1 minus sin square x dx. Here minus sin raised to n minus 1 x into cos x plus n minus 1 into integral of sin raised to n minus 2x into 1 minus sin square x into dx. Then here we can multiply this 1 minus sin square x by the sin raised to n minus 2x. This term we can multiply this whole bracket by the sin n minus 2x. Then next step, minus sin raised to n minus 1 into x into cos x plus here n minus 1 as it is into integral of sin raised to n minus 2x. Here sin raised to n minus 2x into 1, it is sin raised to n minus 2x into here sin raised to n minus 2 into sin raised to 2x. Here minus as it is, then sin raised to n minus 2x into sin raised to 2x. That means sin raised to n minus 2 plus 2. Then minus 2 plus 2 get cancelled. Then we got only sin raised to nx dx. Then after that I is equal to minus sin raised to n minus 1 x into cos x plus n minus 1 into integral of sin raised to n minus 2 x dx. This all terms as it is. Here we can multiply this n minus 1 into this term and this term. Therefore n minus 1 into integral of sin raised to n minus 2x dx. We can separate integral. Then minus n minus 1 into integral of sin raised to nx dx. Here integral of sin raised to nx dx, this is the repeated integral. That means firstly we have to consider equation number 1, that is I is equal to integral of sin raised to nx dx. So we can replace this term, that is integral of sin raised to nx dx, by the I from the equation number 1. That is therefore I is equal to minus sin raised to n minus 1 dx into cos x plus n minus 1 into integral of sin raised to n minus 2 x into dx minus n minus 1. This whole terms as it is, and here integral of sin raised to nx dx is replaced by here I. Then this minus n minus 1 into I, this goes to right hand side, so it will becomes plus. So I plus n minus 1 into I is equal to I sin raised to n minus 1 x into cos x plus n minus 1 into integral of sin raised to n minus 2 x into dx. Then here I plus ni minus I, then we can multiply the I to the bracket. Therefore I plus ni minus I is equal to minus sin n minus 1 x cos x plus n minus 1 integral of sin raised to n minus 2 x into dx. This right hand side as it is, only calculation is that here we can multiply bracket by the I. Then here plus I minus I get cancelled, so only ni is remaining. So ni is equal to this, thereafter this all terms it is as it is, minus sin n raised to n minus 1 x into cos x plus n minus 1 into integral of sin raised to n minus 2 x into dx. Then here I, this n is goes to here denominator, so it will becomes 1 by n and this minus sign. Therefore I is equal to minus here 1 by n into sin raised to n minus 1 x into cos x plus here n minus 1 and this n goes to denominator, so plus n minus 1 upon n into integral of sin raised to n minus 2 x into dx. So finally we got integral of sin raised to nx dx is equal to minus 1 by n sin raised to n minus 1 x into cos x plus n minus 1 upon n into integral of sin raised to n minus 2 x into dx. In this way we can solve this integral, or we can prove the reduction formula. Here sin raised to nx dx, we can reduce this power n into the here n minus 2. So that's why it is known as reduction formula for the sin raised to nx dx. So yes friends, thanks for watching our video. In the next lecture we can continue with the integral of sin raised to integral of cos raised to nx into dx. Till then, goodbye.
Now, what's your vision?